All right, well, good evening, and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here at Kopernik, and it's great to be back having our Friday night program. As we've been looking for some speakers the last couple of weeks, last month or so, I think all my speakers have been out on vacation, so we've been doing some casual observing, which has been great. But I really do enjoy these evenings where we get to talk about a wide range of topics. So Kopernik, a little over 50 years ago, got started here as a public observatory. Last year we celebrated our 50th anniversary, and now we're sort of looking toward the next 50 years. Our website really gives you a sense of what we got going on. So we always tell you what's up. So tonight's program is going to be about what's happening to Saturn's rings. But any programs we've got coming up, like we have a program called Kopernik Kids for 3 to 6 year olds. It's done once a month, and so that's starting back up again. You can go up here and go to our classes and programs, down to public programs, and you can sort of see what's coming up. So last week it was a casual night of observing. This week it's what's happening to Saturn's rings. Next week is Powering the Future, a path to clear energy, a clean energy career. And then the first weekend in October is our Astrofest, and combined with the International Observe the Moon Day. This is a 2-day event, and they will talk about fall skies. And then later in October, we have a professor from Binghamton University, Carl Lippo, who does research on Easter Island. Those big moas that you see here, they weren't carved out of the rock that was sitting there, and so they're going to talk. So he'll be up to talk about Easter Island and what these are about and how did they get there. So you can always go to our website for that. During the summer, we do a very extensive summer camp program. This past summer was our 33rd year, where we had students from as young as going into second grade through high school. Come up for a day camp, and again, the topics varied from just sort of a general science orientation to we did some work with virtual reality and augmented reality, 3D printing. I did a program where we took a weather balloon payload and launched it, and it went up to 100,000 feet, and we were able to capture most of the. We had a problem with the payload this year, but very often we're able to get the whole payload back and then look at the videos for that. We're now just starting to do our school programs. Both schools will come here, but also we will go to schools with our programs. We have a portable planetarium that we can take basically anywhere. And I don't know if you happen to notice, but you got a great new STEM van that's very, very beautiful, beautifully adorned. But what's great is that it allows us to take our equipment out into the public. So by show of hands, who's here for the first time or not since your 4th grade field trip? Okay, a few of you. Who here are members? Oh, okay, there's a few, not everybody. Okay, so the people who raise their hands second have a valuable piece of information. What a Kopernik membership is. Again, we are a nonprofit, so we're not funded by any university or any other foundation. So it's all through programs and memberships that we're able to survive. So we belong to what's called the ASTC, Association of Science and Technology Centers. And your Kopernik membership card gets you into 380 other science centers. You could go to the Robertson Museum. You could go down to the Franklin Institute down in Philly, or the Intrepid down in New York City, all for free. And very often, if you're bringing your family down, you'll find out that just the cost of a family membership is less than what it would take your family to go into, like the Intrepid, for one day. So if you like this kind of place, consider getting a membership. But as I said, one of the things I've really enjoyed about being here at Kopernik is these Friday night programs, and we live stream them. Ever since COVID happened, we started doing that during that time. But once we were finally able to get people back in the room again, we continue to do it. Now we have nearly 14,000 subscribers on our YouTube channel. And if you just go to our YouTube channel, you can actually see, let's see, what's our history playlist? I'm sorry, videos. These are live videos of various programs that we've had. And you can look at the last 5 years worth of programs. Along with the Friday night programs, we also do some observing sessions. And so when we've had lunar eclipses, some solar eclipses, when some of the local astronauts have launched, we'll do a watch party for that. And what's been great is, especially like with the eclipses, people will, from literally around the world, will be watching and be commenting on the chat. And there was one eclipse a couple years ago that people were saying, we left NASA's live stream because we like yours better. And it's all actually due to our speaker here. Jenny Cartie is our live stream astronomer and does a great job interacting with people through the chat. So, actually, I was going to say we didn't have okay, never mind. I was going to show them the quick,
eclipse?
Yeah, the eclipse.
That's it would be under videos because it was an uploaded.
Okay. Item. Here we go. So this was
regardless of the kind of essay they write, many students today use AI to help. When used properly.
So this is a time lapse that Jenny did of the lunar eclipse that we had back in March. Oh, sorry. So she had to change the exposure so that we could start to see the moon when it's fully in eclipse. And there's that blood moon. And you notice that wasn't the end of the Earth, right? Every eclipse will always have that. What she's doing is you're seeing the long wavelength light. The red light is the part that refracts through our atmosphere. And then we'll come back to sort of full exposure. So this whole, what you saw in 1 minute took, what, 3 hours?
It was a few hours, yeah. I can't remember exactly how long that one was.
But anyway, so these are the kinds of things that that we offer here at Kopernik. But what I'm going to do now is turn the dais over to Jenny Cartie, one of our educators, our technology manager, and the floor is yours.
Okay. Thank you. It sounds like my mic's working, but may want to double check the level. All right. So hello, everyone. Welcome to Kopernik Observatory and Science Center. Just so I get a sense of newcomers and returning visitors, raise your hand if you're new to Kopernik, just out of curiosity. Okay. Well, I'd say that's about maybe a little under half. So welcome to all the newcomers. I think this should be a really great talk to just introduce you to not just Saturn, but some tools that you can use and things that you can get familiar with astronomy. So that's my goal, is to keep it accessible and really focus on the viewing aspect of it as well. So we'll talk about a couple of different events happening this fall. Very focused on Saturn itself. We will have another program called Fall Skies coming up on October 10th that covers more of what's out in the fall. But Saturn is a particularly interesting target this season, and that's what we're here to talk about. So let's dive in. Let me get this slideshow going. Here is what we're focusing on. I'm going to turn this front light off. That should make it a little better for you. Yes. All right. So here is our subject matter tonight. This is Saturn. And we're already seeing some interesting things. A lot of these videos you'll see in this come from a program called Space Engine, which is a very cool space simulator available on Steam. So if you ever get the chance to download it and try it, I really recommend it. You get some absolutely gorgeous views of the planets. What you're seeing here is not just Saturn, the planet, but also its ring system. Notice it's kind of in shadow a little bit. That's interesting. Normally you'd see the rings nice and bright, but here they look a little dull because they're in shadow. We'll talk more about why. And then throughout this video too, you see some other interesting events happening. First, you see this moon trekking along in the path of Saturn's rings. That moon there is called Pan, and it creates this division in the rings, this gap. And as you see it just traveling along that path, it's cleaned it out. You also see some, at least earlier on, oh, there's another one. There's a couple of them. A couple of these shadows projected onto the moon. What happened back last year, April 8th, 2024? What happened on that date? Anyone remember? That was the eclipse, yes. And maybe it wasn't the most memorable date because it was pretty cloudy, at least around our area. But if you traveled that day, maybe you got to spot it. My point there, though, is that these are eclipse events. When you see those shadows happening on the surface of Saturn there, they're eclipse events on Saturn. And because Saturn has so many moons, these events happen pretty frequently. And there's a tiny eclipse event there, I think coming from, might be even this moon right here. There's a very small moon here tracing along this larger moon there. So even just in this video, there's so much to see with Saturn. And of course, this is like if you were in a spaceship, if you were the Cassini probe and you were flying around Saturn, but we can get some interesting views with telescopes as well. So let's carry on. Here's some ideas that we're going to discuss tonight. So we're going to go through some basics of Saturn, just to set the scene, get some planetary facts right away. And then that will lead us right into Saturn as a fall observing target. After that, we'll focus more on Saturn's rings. Saturn has the best and most complex ring system in the solar system. So we're going to put emphasis there, and there's something pretty interesting. That's the name of this talk, really. It's what's happening to Saturn's rings. That's a big focus for us. So we're going to answer that question. And then we'll talk about the transit of Saturn's largest moon, Titan, which is an event that's happening tonight. And it will happen one more time. And then you have to, one more time in October, early October, I think it's the 2nd. And then you gotta wait until 2038 to see it again. So now's the time, and we've got you covered there if you don't wanna stay up late tonight. I'll talk more about it. All right, so Saturn basics and fall observing. Now, if you know Jupiter, we'll only mention this briefly just because it's a really nice visual of it. But if you know Jupiter, Jupiter has this big storm system on it, amongst all sorts of other storm systems. They're basically hurricanes across the surface. We got some buffering going on, but that's okay. Over here, though, if we get this video to start playing out again, you'll see this at the top. This is the North Pole of Saturn. This is Saturn's storm system, and it's pretty complex, and it takes on this hexagonal shape. So we don't really get to see that storm system from our perspective here on Earth, but because we've sent spacecraft there, NASA has sent spacecraft like the Cassini mission, we have really great data on what that storm system looks like. So kind of a neat look at the North Pole of Saturn. All right, let's review some basic facts about this planet. So most important one, perhaps, if you're just naming them, right, numbering them through the solar system, Saturn is the 6th planet from the sun, and it's the 2nd largest planet in the solar system, second only to Jupiter. But its rings system really does dramatically improve its view. If we're just comparing the two through telescopes, looking at Jupiter and looking at Saturn, very different experiences because of Saturn's rings. So going through just some specs here, a spec sheet for Saturn. I don't like to focus too much on numbers. Like, this diameter here is 74,897 miles across. That's how wide Saturn is. What does that really do for you? Not a lot. I think just kind of framing it up, especially if you've traveled Earth a lot and you've gotten a sense of how long it takes to get from place to place. Saturn is 9 times wider than the Earth. And that's what makes it one of the largest planets in the solar system, but also it's a gas giant. It's a completely different type of planet to our terrestrial Earth. So this is mostly made up of gases like hydrogen, mostly hydrogen, 96%, and helium, about 3%, and all sorts of trace other compounds and gases like methane. Then the mass of Saturn, 95 Earth masses. Again, framing it up into something, I mean, you've never held the Earth before, but at least we know our planet a little bit. So framing up with respect to Earth. The distance from the sun, average distance, because it does change a little bit, is 9.5 astronomical units. And an AU is the average distance from the sun to the Earth. So it's 9.5 times further away from the sun than we are from the sun. And the length of a day is quite a bit shorter. For such a massive planet, this rotation period is really quick. It's about 10 hours and 34 minutes for Saturn to spin once, giving it its day and night. Our length of day here on Earth is 24 hours, right? Just about. So this is a faster rotation for a much bigger planet. And you can imagine that contributes a lot to things like the storm happening at the top of the planet. It's a lot of rotational speed. And then orbital period is 29 years. What's orbital period equivalent to? Once around the sun, yeah. So that's our year is 365 days. We're putting Saturn's year in perspective with Earth's year. So this is 29 Earth years for Saturn to go once around the sun. That's a long trip around the sun. And then we have the total number of moons, which over the last year and a half or so, this jumped up like crazy. This was like in the low 100s, somewhere in that range for a while. At one point, Saturn and Jupiter were kind of in competition, like who's going to discover more moons around Jupiter versus Saturn. But Saturn really just blew the competition out of the water. Saturn now has confirmed 274 moons around it. A lot of them little tiny moons, but pretty extraordinary. I think Jupiter is topping out around 90 nowadays. Maybe they'll discover more, but Saturn definitely has the lead at this point. And then its composition we did highlight before. So yep, hydrogen and helium primarily. All right. Carrying on here. So we are going to highlight Saturn's rings here for a moment. It's a critical part of Saturn, so it's going to fall right in our basic discussion. And like I said, Saturn's rings are the most complex in the solar system. They're not the only planet with rings. All of the outer planets have some kind of ring around it. Even Jupiter. It's very faint, but it does exist. Saturn has a very apparent ring system, and it's almost always observable. So this is what's weird about them disappearing. We'll talk about that in a bit. But you can see the labeled rings here, some of them, like A ring and B ring, then we have C ring, and then D ring closer to the planets, especially these three, A, B, C, very easy to spot. Those are really what you think of when you see Saturn's rings through a telescope. It's really the ABC ring. But then you go further out, you keep counting. D is a little fainter. And then out here, you have your F ring and your G ring. And then E ring way out here, all the way out to Titan. Very diffuse ring system. So these two here, very difficult to spot. Not something you would really see in a telescope, but the Cassini spacecraft has observed those rings. I'm going to mention Cassini several times in this talk. Sadly, Cassini is no longer orbiting Saturn. There's no spacecraft orbiting this planet at this point. Several years ago, the Cassini mission ended, which was planned. Just eventually, the craft runs out of fuel, and you got to end the mission. But most of the imagery you see today about Saturn came from Cassini. So, and that's where a lot of this data is coming from as well. Cassini imaged these rings by traveling to the backside of Saturn, where you're in shadow, and then all these rings are highlighted by the sun. So then it shows you some of the moons, some of the larger moons around Saturn. All right. We're not getting too much into ring structure today, but I think it's important just to show you the basic structure of the rings of Saturn. All right. So we're going to show you how you can observe Saturn and where it will be in the sky in just a minute here. Before we switch over to that application, I want to highlight Saturn will be at opposition on September 21st. So coming up in just one more day, a couple days. So let's jump into here. I can kind of show you what that means using this platform, which is called NASA's Eyes on the Solar System. And here you can take a look at a 3D image of not just all the planets out there, but even it will highlight dwarf planets, asteroids, and missions too. Like here close to the sun is the Parker Solar Probe. That's the spacecraft it's the closest a spacecraft has gotten to the sun. You can see how quickly or how close it zooms past. So this is really powerful software, but we're just going to use it to highlight where Saturn is and where Earth is right now. So here's Earth, this little blue circle where my mouse is. And if we zoom out, and this is about live, we can see Saturn. And do you see how they're kind of stacked right up, and you can line all three of those up with the sun? So you have Sun, Earth, and Saturn lined up. So that what this really means is when the sun sets in the sky, Saturn is rising. So they are opposite in the sky, 180 degrees from each other. So as observationally, that's all that means. Sun sets, Saturn rises on that day. And it also means that we are about the closest that we can be to Saturn for our orbital period, for our trip around the sun. So this happens about once a year. You do have to play a little bit of catch-up, because Saturn will move through its orbit. So every time you pass Saturn once, you do have to play catch-up. But basically once a year, you get to see the opposition of Saturn. And because it's closer, that does technically mean, and looking at Saturn in a telescope, it will appear a bit bigger. There'll be slightly more detail potentially. It's an ideal time to observe Saturn. But for these outer planets, even Jupiter, the impact is not nearly as significant as something like Mars. So viewing Mars at opposition versus when Earth is either ahead or behind it is very significant. Like Mars right now, not great to look at because we're not very close to it. But that's because all the terrestrial planets are all clumped together. Saturn's way out here with its 29-year orbit. That's a long time. And that means it's really far away, too. So the impact isn't as significant. If you see this little blue circle here, I should point with the mouse, too, so that Livestream can see. This little blue circle that I just highlighted, that's Earth's orbit. So that's the distance that's changing. When Earth is over here, it's really almost an infinitesimal distance that's not super consequential. But again, there is, if you're very careful about how you observe and how you look at these objects, like let's say you take a picture at one point when Earth is over here, further back, and you take a picture of Saturn, it will look smaller than it does right now. So there is a slight change. It's just, I don't want to say don't look at Saturn when we're not at opposition. That's not practical at all. Look at Saturn whenever Saturn's out, because it's amazing. All right. Now I think the next slide I had. So yeah, Saturn observing using stellarium. That's what we're going to get to next. So stellarium, for those that haven't worked with it at all, we use this a lot at Kopernik. In our computer lab, up here, it's basically your at-home planetarium. You can download it on your computer. There's smartphone apps, both on iOS and Android. And there's a web-based platform, too. So even if you just want to use it in the browser, or if you only have a Chromebook, Stellarium works basically wherever you are. And like I said, it's your at-home planetarium. So you can set it up for your current location, and you can see a simulation of the sky pretty much at any date and time you want. There are some limitations, like you can't necessarily go millions of years into the future, but you can go, I think, up to 100,000 years into the future, or 100,000 years back in time. So pretty good plus or minus flexibility there. And you can look at things in the daytime. You can do things like turn the atmosphere off. So that's especially important if you want to see what's out in the daytime. So if let me turn it back on for just a sec, and we'll go to daytime hours where the sky brightens up. So in our real sky, we can really only see the sun and the moon, at least by eye. But in Stellarium, we can just turn that atmosphere off. Who needs to breathe, right? And then you can see what's out. All right. So powerful tools here. You can also turn off the ground. That's fun. So you can see what's below the Earth, what's yet to rise or set, and what will never rise, because there are a lot of stars out there in the southern hemisphere that they only get to see versus our northern hemisphere. So that's powerful too. Let's go back to current time. This little hourglass will take us back to current time. And we can turn on some constellations. If you've been in a planetarium before, this is probably really familiar to you. It's just we're using it on a flat screen versus an all-around screen. Okay, then you can just click and drag. You can look at all the sky at once as a star map, so you have your compass directions all around. You get some really crazy views with this. All right, let's point to the southern sky. And there's even artwork for constellations too, for the mythology. There's layers and layers to this application, and we'll only point out a couple of things tonight. But our goal here right now is to observe Saturn. So let's slide over to where it is in the sky right now at about 8:30. So Saturn is rising in the east, right? It's been hour and a half, something like that, since the sun set, and Saturn should be higher up in the sky because it As soon as the sun set, Saturn rose up. So it's rising in the eastern sky, climbing and climbing. And here's a really powerful trick with stellarium. When we click on an object, we get our little crosshairs dancing around it. And if I hit the space bar, that's going to center me to Saturn. And with the scroll wheel on the mouse, or you could pinch to zoom on a touch screen, you can zoom in. Just like that. And get a telescopic view of Saturn. This is with a really good telescope. And you can see the moons of Saturn here labeled. There's that Titan. Notice its position there. It's going to keep getting closer to Saturn tonight. And you can see those rings, kind of. You can clearly see why we're talking about how they're disappearing, right? Because we've looked at different images of Saturn tonight alone. You've seen your own images of Saturn, I'm sure. And usually the pictures are pretty dramatic. You're either looking at the top or bottom of the rings, and they're nice and bright. But here, we're almost looking straight down the disk of the rings. And that's basically looking at a sheet of paper from the side. When it gets to this level, Saturn's rings are so thin. In some spots, they're only 30 feet thick. And that means that, yeah, we really struggle to see them when they go edge on. They're not invisible right now. In fact, as long as sky conditions are good, even leading up into November, they likely won't completely turn invisible. But we'll talk more about that. For now, let's focus on Saturn as an observing target this fall. So we already talked about, yeah, as fall comes around, I think fall is the 22nd. So it's nearly fall when we're at opposition with Saturn. But Saturn is just going to continue to rise earlier and earlier into the sky as we head further into fall. So let me show you what that looks like, and again, show you the power of stellarium, because we can do quite a bit of time travel. So we're going to center in on Saturn, and we're going to pay attention to its view with respect to the compass directions, and also how high it's climbing in the sky. So first, let's just get a sense. Let's start changing hour by hour. And that should show us that, yeah, Saturn will climb higher into the sky hour by hour until it gets to the southern sky, and then it will start setting. Now this is actually really good news for observing the Titan transit later on. Notice how high it is in the sky there. When we do the simulation with Titan, we'll talk more about that. But if I back up to even just use the hourglass, go back to current time, that was hour by hour, Saturn rising in the sky. Now let's go day by day and see how it changes. So same time, about 8:30, but skipping ahead day by day by day, it does climb higher in the sky. So that means it's rising earlier and earlier. Oh, and here comes the moon. Oh, nice little conjunction there happening on the 5th. Okay. And it just keeps on climbing this fall. So here at about, oh, and we just passed into standard time from daylight savings. So we see we backtracked an hour, but astronomically, the sky doesn't care about that. It's just going to keep carrying on. So we just adjust our clock there. And so here at 7:30 on November 21st, Saturn's pretty high up there in the sky at this convenient hour. And that's what we like about it. In the summertime, when we were observing during our sessions, if people were here heading towards midnight or even later, they would get treated to Saturn because it was finally above our tree line and high enough in the sky. But now, heading into fall, we get to observe Saturn after this program and throughout the entire season. And notice, too, if we keep on going, so I skipped ahead a whole month now to December 21st, to the winter solstice, I guess, yep. And here's Jupiter coming up. And Jupiter is going to go through the same process. It's going to rise earlier and earlier. But even here, come December, we'll be able to observe Saturn and Jupiter at the same time. Okay. So back to current time. That's what part of the reason what makes Saturn such a great target this fall. It's just going to keep on climbing in the sky. All right, let's switch over back to our slides. Okay, so we have that reference of, okay, so Saturn's a great observing target. And there's already, we know some things going on right now, like the opposition of Saturn. It's just in general going to be an easy target to observe in the fall. But there's a couple of other events we want to highlight. First, going back now to Saturn's rings and why they look like they're disappearing. What's the astronomy behind that? Now this is, again, that simulated view. You can see those moons zooming around the planet. But what's really, again, really cool about that simulation software is that this is not something you can do in Stellarium, but in that space engine software, you can start to see those FNL rings. So pretty cool there. Very hazy, but that's kind of what Cassini took an image of. And at the end of the program, I'll pass this picture around, which is kind of what this is showing. This is a real picture from Cassini, but I have an image of that coming up soon. All right, so getting into Saturn's rings now. Now, here's just a little experiment I tried. This is called Saturn Through the Years. And this is my personal observations of Saturn and imagery from all the way back in 2012 to pretty recently, actually exactly a year ago today. And there are way better images of this in compositions. And one, I don't like share, you can look them up online. They're pretty amazing. I don't like using other people's images as much as I can, just for copyright reasons. But even still, I thought it was an interesting perspective to see, okay, let me go through my whole entire photo gallery and pick out all the Saturns I have so that we can get a sense of what's going on with the rings. So here, back in 2012, I'm not confident in this timestamp. This image has traveled around, can you tell? So I'm not confident in that timestamp. It may have been even a year or two before this, but that's the date in the metadata, so that's what we have. The reason I say that, though, is because visually here, it looks like those rings are thinner than they should be for 2012. At this point in 2012, they were getting a little bit wider. We were starting to look at them a little bit more from above. I mean, look at the difference, right? From 2012 to 2013, that's pretty dramatic. So this is the only one I'm not confident in. All the rest should be accurate. So then we skip ahead to 2013 and 2015, which are pretty similar. And those ones, again, you're almost looking at the very tippy top of those rings, or as high as we can go. So they're very bright, and they look very large. Then we go ahead to 2020, and part of this, too, is like the processing is getting better, and the camera equipment I was using is quite a bit better. But then here we can also see detail in the rings from the better processing. So you can see this Cassini division here, that gap in the rings. And it's very easy to distinguish the rings from the planet. You can kind of see how they're superimposed on top and then hidden behind the main planet there. About a month later, very similar view, just different processing to bring out those layers of Saturn in the planet itself and the rings too. And then finally, the image I have, the most recent image I have is this one. And this is very dramatic. From 2020 to 2024, you are still looking more at the northern hemisphere than the southern hemisphere of Saturn here. So this is the northern hemisphere here. The southern hemisphere is partially obscured by the rings. Here, we're looking more towards the edge-on rings, and then still focused on the northern hemisphere. We haven't quite crossed that line yet. That happened in March. They call that a ring plane crossing. So in our perspective here on Earth, as we travel around the sun and as Saturn's traveling around the sun, we cross the plane of those rings. And as I said, that event happened in March. So that's where the rings completely disappeared. There was a problem with that date, though. And Saturn was only 10 degrees from the sun in the sky, which made it so you really couldn't observe that safely. The sun was too bright, our skies are too atmospheric, and it really prevented any astronomer from successfully observing this event because of that proximity to the sun. So we got the ring plane crossing when the rings would have disappeared in a telescope back in March. But there's a very similar or very close event happening in November that we'll see in Stellarium in just a minute. Why does this happen at all, though? Well, first, we just got to focus on the seasons. So we know here on Earth we have seasons because of the Earth's tilts. And it's that tilt fixed in its position as it goes around the sun. The sunlight casts at different levels. So let's just go right in order. We just moved out, or we are moving out of the summer. So back in June, we had the summer solstice. And during the summer solstice, that's our longest day of the year, where you have a lot of light illuminating, especially the northern hemisphere. The southern hemisphere is experiencing winter at this point. It's the darkest day of the year for the southern hemisphere. And then we go around to autumn. And autumn means that you're casting equal amounts of sunlight across the northern and the southern hemisphere. And the direct sun is right over the Earth's equator. Keep going around, we have the winter solstice, and that's the inverse, right? So less light here in the northern hemisphere, more light here in the southern. And then the vernal or spring equinox on March 20th coming up next year. Very similar. Equinoxes are equal amounts of light. So that's our seasons. And Earth's tilt is something like 23 degrees. Saturn's tilt is about 26 degrees. Very similar. And because Saturn is also tilted as it makes its trip around the sun every 29 years, it goes through these seasons as well. So the autumnal solstice is happening this year for Saturn. And the view we get is close to edge-on rings. And it's really the ring plane crossing where we actually get the disappearing rings. But either way, when you're near an autumnal solstice for Saturn, Saturn's rings are going to be very close to edge-on. Then you move on to 2032. That's the summer solstice for Saturn. And here we're going to be viewing the southern hemisphere and looking at the southern part of the rings. carry on to the autumnal solstice, and that is edge on again. That'll be 2039. So you see here, it's going to be 14 years before we get these edge-on rings again. Once we move out of this phase over the next several months, we'll have to wait till then to see the edge-on rings, which arguably is good, because it's a novelty, but really when you look at Saturn, you want to see the rings highlighted quite well. And it doesn't last that long either. Then go to 2046, and we experience, oh, excuse me, these are flipped. That one should say your winter solstice, and this should say vernal. But the dates are correct. But this is out here to your summer, where you have the northern. Sorry about that confusion. But the imagery and the dates are correct for those. So let's look at what this is in stellarium. I'm going to get rid of this because I think it's slowing things down a little bit, and pop back in here. So let's focus in on Saturn now. We're going to zoom right to it, and we'll just click through the days to show you how those rings are going to change, leading up to November 23rd. We'll talk about why that is in a moment. But clicking through the days, yeah, you see the moon zooming all sorts of ways as they orbit around Saturn. I am going to turn off the atmosphere. You don't need to hold your breath. But that atmosphere is turned off so that we can just focus on Saturn. We don't get any of that gradient going on either. And we keep carrying on. The rings are getting more and more edge-on at this point, and it won't be until we cross November 23rd that they will start to grow again. So here is our most edge-on perspective of Saturn's rings. And again, as long as the sky conditions are good enough, there's enough sunlight casting on the rings here that we should see them highlighted a little bit. But some parts of them are even more edge-on, so these are almost hairline here and here. It looks like at the edges, they'll be more pronounced. So I'm very curious to see what that ends up looking like. But this is the date where we have the best chance of seeing a ringless Saturn. Again, this did happen back in March. I got to turn off the ground to show you this one. So if we skip back to March, they did actually go edge-on. So we're in April. It was right about here. Yeah, it looks like March 23rd. That is when they went exactly edge-on. So really, you would only see the shadow of the rings across the equator, and that's about it. So there's this difference between a true ring plane crossing, where we get perfectly edge-on rings, and then this next one in November that isn't quite a ring plane crossing. And this is where we can get super advanced with stellarium. So let's have some fun here. Bear with me. I gotta set this up. We're gonna go back to Earth just to keep our perspective, and I gotta turn the atmosphere back on and the ground. And I'm gonna return us to the current date, so Saturn's out in the sky. Gotta look over here. There's Saturn. So, as I mentioned, you can set this up for your current location, but we're gonna do something a little different. We're gonna go over here to the Planet tab. And we're going to skip on down to Saturn. Who knew that there's grass and buildings on Saturn? It doesn't change the landscape for you. I got to do that a separate way. But we are technically on Saturn right now. I'm going to even bring us right to the equator. We're just going to go 0 degrees for both latitude and longitude. Let me. 0. We'll zero both of these out so that we know for sure, yes, we are at the equator of Saturn right now. And Saturn's rings align with the equator. That's important. Okay, so we're at the equator, and just to be aesthetic here, we will bring our landscape to Saturn. There we go. Goodbye, trees. Now things make sense in the world. All right. We'll turn the atmosphere off again. And we need to find Earth. So we're going to bring up the search window, type in Earth. And yep, as expected, it should be right up close to the sun there. And because we've maintained our date and time here, you don't really notice it much in the sky, because this is the night side facing us right now. As if we teleported back to Earth, it'd be nighttime and we'd be looking up at Saturn, right? So you're seeing this all play out almost in 3 dimensions live, which is pretty cool. So now we need to bring up Earth's orbit. And show orbits. There we go. And this is going to show you the highlighted object's orbit, which is good, because otherwise it would get crazy if it showed us all the orbits. So this red ellipse here is Earth's orbit around the sun. And then the last thing we're going to do is bring up the equator for Saturn. So this is a projection of the equator. So just like Earth has an equator, Saturn does too. And sometimes to help us understand what's going on in the universe or in the solar system, it helps us to throw that equator into space. So you just take it from the circle around the Earth and you expand it out into space. And that's all we're doing here. This equator, this blue line that we just mapped on the screen, lines up with the rings as well. So we bring ourselves to oh, the angle measurement isn't on here. Oh dear. That's okay. I think I remember the measurements thereabouts. So if we could bring this back to March. We gotta turn off the ground because that's getting in our way right now. Do you see how, as Earth orbits the sun, it passes through Saturn's equator? So we skip between these two. The 23rd and 24th is where, remembering that the equator lines up with the rings, this is equivalent to that ring plane crossing. So this is why the rings disappeared, because this all lined up just right, where as Earth traveled around the sun, it passed through the equator of Saturn, or the ring plane. That's the same thing. So now if we skip ahead to November 23rd, that's not the same thing. That's not the case. At this point, because Saturn has moved through its orbit, it's continuing on its journey through its seasons, there's no way that Earth can cross that plane. So we can only get very, very close to it. And it turns out that this distance here on November 23rd is about 0.4 degrees in the sky. So that's pretty close, and it's close enough for them to almost disappear, but you only get true disappearances when we cross that plane specifically. But if we look before and after, like if we skip ahead to a whole month, look how far off it is now. That's more like 30, I think it's like 32 minutes off the equator there. And same thing, skipping back to October, it's still pretty far from that. So it's purely because of how Earth is moving around the sun through its orbit and how the equator aligns with that orbit that we get this one more chance to see the rings disappear, which is, as I said, is good for us because back in March, Saturn was just too close to the sun to safely observe. Okay, so that's why the rings appear to be disappearing in the sky. It's all about this ring plane crossing phenomenon. All right, let's back out. Let me see how we're... I do have a couple of videos that I'm going to skip for now. If it comes up in a question later on, that's fine. I just want to make sure we have enough time for this last part. Those videos basically just highlight that Saturn's rings will disappear. They will actually disappear. We won't see that in our lifetime, but rings are not permanent structures around a planet. They will fade over time as that material rains down. Gravity eventually pulls it down, and it rains down on the surface of Saturn. And this takes millions and millions of years. So anywhere from 100 to 300 million years in the future, Saturn's rings will be gone. And then maybe another planet will have some rings, like Mars. We didn't even get into how rings form. That's a whole other topic that we could get into. But trying to keep it focused on the observational aspect. Maybe that brings to mind some questions that we can answer during Q&A, though. Okay, let's jump now to the last major event happening. And this is happening tonight. And it will happen once more on October 2nd, though a much briefer occurrence there. And this is the transit of Saturn's largest moon, Titan. And if you look here in the video, you see all those moons spinning around Saturn. Titan is a little bit more rare to see these transit events because it's much further out from the planet in its orbit. So this event requires a bit more time to get things just aligned right. But we saw there this kind of shadow. I'll back up it'll roleplay. Yeah, so we'll see it happen again here. This is Titan. This is Saturn back here with those edge-on rings. And then this back here is the shadow of Titan. Remember we talked earlier about those little eclipse events that can happen with these gas giants with so many moons. And through a telescope, there's so much contrast between the bright surface of Saturn and that dark shadow that becomes visible, especially because Titan is such a large moon. And also the distance has a role to play in this as well. Because it's further out, so the shadow has longer distance to spread out a bit, so it's a very exaggerated view. The planet the moon of Titan is much smaller than Saturn itself. It's a big moon, but it's much smaller than Saturn. But look how big that shadow is. That's not proportional, but it makes sense when we're talking about these planets. Okay. Couple of Titan facts I can throw at you here while we watch this video. This is just of Titan in orbit around Saturn. And the video started with Titan's cloud layers. Titan is very cloudy, kind of like Venus. But this object is still very, very cold. What that tells you, though, is that Titan does have an atmosphere. You can't have clouds on a planet or a moon without an atmosphere. So Titan has clouds and it has an atmosphere. The atmosphere is mostly made up of nitrogen. That's pretty similar to Earth. Our atmosphere is also mostly nitrogen. The clouds themselves are made up of methane, primarily. So, very interesting fact about Titan there is that methane, well, there is a methane cycle. On Earth, our clouds are made of water, right? And we have our clouds raining down on us, pushing that water cycle forward, where we have aquifers all through the, like we have aquifers all around here. So that's underground water. And we have rivers, and we have creeks, and ponds, and lakes, all sorts of things. And that's good for our biology here on Earth. We like water, right? But on Titan, it's not a water cycle, it's a methane cycle. So a lot of what you're seeing here, some of these dark patches, there's all these little speckled ones up top, the North Pole of Titan. Those are lakes, those are rivers, those are seas, but not of water, of methane. And because there's this cycle going on, Titan looks so much like Earth. It's got this nitrogen-rich atmosphere. It's got lakes and rivers, this liquid cycle playing out, raining there. It's just very, very cold. You can't, in our atmosphere, methane exists as a gas. But you drop that temperature down several hundred degrees, and you get methane playing out this liquid cycle on this planet, on this moon. I always do that with Titan because, like, when you look at this, it's like, that's a planet. And it would be if it wasn't stuck in orbit around Saturn. So this is the second largest moon in the solar system. It's 1.5 times larger than Earth's moon. It's only second to Ganymede around Jupiter. Jupiter, I think Ganymede is about 2 times larger than our moon. This is 1.5 times larger. So Titan is a very interesting world. And there we go. Do want to mention, too, that they will be sending a spacecraft to Titan. This is what it looks like. This is called Dragonfly. It looks small, but it's pretty big. And it's a drone that will fly around in the atmosphere of Titan, exploring those lakes and rivers. Having an aircraft on this world will make it a lot easier to bounce around to different locations and explore. Powered aircraft have already been tested on other objects in the solar system. The first one was Ingenuity around Mars, or on Mars, that flew there with Percy. So this is going to be a very sophisticated spacecraft exploring Titan. It launches in 2028. Won't get there until 2034, though. A little bit of a wait. But just a little neat fact about it as well, that we have this spacecraft that's going to go to Titan and really give us some amazing views. It won't be the first spacecraft to touch down. That goes to the Huygens probe that was part of the Cassini mission. It did land on Titan, but this will be the first powered aircraft and object that will have the ability to bounce around to different locations. All right, so this is what we're interested in for the event, though. And I do want to mention, this is happening at about 1 o'clock in the morning, heading into, like, tonight into tomorrow, right? So it's happening this evening. But it's 1 a.m. to about 3:30 a.m. And because of that, we will likely be closed at that point. But I will still be here. And we will have a camera hooked up to our 6-inch telescope, and we will show you this transit event happening through the telescope. And then hopefully, if we collect enough data, we can put together a nice little animation. Because a single instant through a telescope is, like some of those pictures before, especially the later ones, were processed through stacking, which means you take a whole bunch of images of an object and then you put them together and only use the best details, the clearest details from each one. And when you piece that together, you end up with a really strong image. So it's really the processed version of this that will look much better, but even live, we should be able to see a little bit of the rings, the main planet, and we should be able to see that transit event happening. So that will be available to you either tonight or tomorrow at your leisure. So let me jump to Stellarium one more time here. Oh, we got to reset. Let me just back out. I think it'll bring us back to our defaults and not leave us stranded on Saturn. Oh, it's loading. Okay, yes, it looks like we're back on Earth. Oh, yes, we are. There's Saturn. All right, so we're going to zoom in. And we saw this view earlier. This is Saturn as it is in the sky right now. And we see Titan, a little orange ball over here. And as we approach 12:30, 1 a.m., it's going to be getting closer and closer to the disk of the planet. And I'll bring my clock back on so we can skip ahead. Well, we could even just use the media bar. Let's do that. So we're fast forwarding now through time. Our minutes are flying by here. And as we go through time, you can see Titan starting to inch closer and closer to the disk of the planet. Again, keep in mind, Titan is way further out than any of these moons here. But when we're looking at it from our perspective here on Earth, it looks like Titan's getting close to Saturn. But again, think about this as foreground and background. Saturn's in the background, Titan's in the foreground. Titan is closer to us than Saturn. Okay, let's skip ahead even a touch further. And now we're really zoom in. So as we approach that 1 in the morning, we get our transit event. So here's about 1:40 later on tonight, early morning tomorrow, I guess. And you see, this is really a double transit event because you have, well, even maybe you could call it quadruple, because you have Titan transiting with its shadow apparent. So sometimes, like during these last several months, during these transit events for Titan, you've only had the shadow projected, and Titan may have been a little bit too high above Saturn. But because we're getting closer to this equatorial region, this equator region, as we head into November, now Titan is getting into the disk of the planet. So we see the moon itself transit, which my hope is we'll see that, at least a little bit. But you'll also see the contrast of the shadow. That's called a shadow transit. So you can have a true transit where the moon actually goes in front of the planet, or you can have a shadow transit, and that's where you only see the shadow cast on the surface. In our case, we get both tonight. Not always the case. And then also, we have little Enceladus here, which is much closer to Saturn. And I don't think we'll be able to spot this one. Our resolution on our telescopes isn't quite that good. But Enceladus is pretty tiny here, and its shadow is also really tiny because it's much closer. So there is a secondary transit event happening with Enceladus. So Titan and Enceladus are transiting Saturn at about the same time. Pretty cool. So that's what we're going to try and cast tonight. And our live streams always record after the fact, so you can view it at any point in the future. So you could always just go through and scan that video and see what this event looked like in a real telescope. Just out of curiosity, there will be one, I think, on October 2nd. Or maybe it was October 4th. I think I saw it there for a moment. Where is Titan? Titan's way out here. I gotta turn the ground off. No, it's way out. Oh, there it goes. Okay, so there is this one more transit with the shadow transit, and that looks like it's happening on October 6th. So you can see that shadow just touched the North Pole of Saturn. And then lastly, to wrap up our view of stellarium, where are we going after all this? In the next 6 months, in the next year, let's just skip ahead a full year. We'll go back to current time, and we'll skip ahead a full year. And this is 2026, September 19th. And we're starting to look at the southern hemisphere at this point. So we haven't seen a view of the southern hemisphere in that form for about 15 years. Because that cycle, as it orbits, as Saturn orbits the sun every 30 years, has to play out. Again, if you go a little further, 2027, we're looking at more and more and more, and then 2032 is when we should see the rings at their biggest apparent point for us here on Earth. So the next several years, we're focused on the southern hemisphere of Saturn, and there's no way around that unless you send a spacecraft out that way. So yeah, there isn't really a hexagonal storm down at the southern hemisphere. I believe there's only one at the northern hemisphere. But you can still see these layerings of the different gas layers of Saturn. They're not as apparent as Jupiter, but I think the storm is only focused on the north. Yeah. And again, it's not really something you can see all that well in a telescope anyways. Our best images definitely came from Cassini for that spacecraft. All right. Wrapping up here, I just want to show you one last thing. So this is the larger view. This is more zoomed in up here, but this is the overall view with Saturn incorporated and everything. This is that Cassini image from behind Saturn. So the side of Saturn you're looking at there is a night side of Saturn. Okay, so the rings are backlit by the sun, meaning that you can catch those very diffuse rings on the outside. I'll come down this row too, show everyone. Okay, here. All right, so now if we zoom in on a picture like this, I just love this image so much, and I can't talk about Saturn without showing this. We see all sorts of stars and things in this image, but there's this one right here. What color is it? Can you tell? Blue. That is Earth. So this is a real image from Cassini. We kind of got this perspective in Stellarium. This is a true image of that spacecraft looking back at its home and seeing Earth itself there. This lines up with, I think this image even is called Saturn's pale blue dot. And that's a quote from the famous Carl Sagan. And it's pretty fascinating just to see, like, this is how we see Saturn in our skies, right? It's just this dot in the sky. But here's Earth as that same little pale blue dot around Saturn. So really incredible image that came out of the Cassini-Saturn missions. And that does wrap up our talk. So lots of events happening with Saturn coming up. And again, the best thing is we'll be able to look at it tonight. Do we want to go through Q&A?
Sure. Any questions? Oh, we got a few. All right. Great. And all right.
Why does the ring disappear?
Oh, so there's the two layers of it, right? There's the rings disappearing right now as we head into November because Saturn goes through its seasons. And sometimes during that path around the sun, we look at those rings edge on. But then there is the truth of it too, that Saturn's rings will disappear in a few 100 million years. So not something we'll get to experience there. Ours is just a play of perspective. So as Saturn's rings tilt up and down in its orbit, we see it change pretty dramatically.
All right, got another question here.
Does the Earth or does Titan have any life organisms?
Oh, I'm sure that's what they want to find out. It's because of this such an active geology there. In Titan's case, it might be, if there is life on Titan somewhere, maybe it's a little different to Earth because the conditions are very different. But there's also the possibility with Titan that there is subsurface flowing water underneath. So that's what they really want to find out. What's going on inside and what's going on the surface, and could that lead to any discovery of life? As you may have heard in the news, there's really good news about Mars right now. It's not conclusive news, but it's very good news about finding evidence for past habitability of the red planet. So I'm not going to get all the way into that, but look up some NASA news about that because it's very exciting.
We do have a question from the live stream from Damiana. Asks, may I ask why Saturn looked blue in the photo taking in 2013? So you're going to have to scroll way back to your...
Oh, yeah. So let's go. Where's the scroll bar? Here it is. There's all the images. Purely just these three, actually these four. So 1, 2, 3, 4. Those images were taken with a phone hovering over the eyepiece. So in a way, this shows you the progression of phone technology over the years. This was the camera I had available to me at the time. So the colors are wild, and who knows what young Jenny did processing these. I'm sure I didn't know what I was doing at all for some of them. So those are very early days for me. But that's why it's purely like, how did this camera see this version of Saturn through the eyepiece? Colors can get wild. These are truer. The redder tint on this Saturn may have been because it was lower in the sky, which is more an atmospheric quality of Earth rather than Saturn itself. But more often than not, when you view Saturn, it comes out something like these two, kind of this tan color.
We have a question in the back here. Give me a second.
Curious, how old is the light that we see on Saturn, or from Saturn?
Oh, good question. I'm not going to remember Saturn all that well. I know from Earth to the Sun, it's about 8 minutes. So maybe 91 minutes, something like that. Yeah, I think it's something in that range, 90 plus minutes. That's my best estimate right off the bat here. But yeah, long ways out. So inner solar system, it's all pretty quick relative to what's going on in the outer. Yep.
Any other questions? Oh, here we go. Go in here.
I wasn't quite sure when you use the term in opposition, what does that mean?
Yeah. So if we go back, I may have gotten rid of the NASA tab. I can just explain it. So if we have the sun at the center of our solar system, right, and then out here is Earth, and then following that is Saturn. They're all stacked up in line with each other. And so Saturn is opposite to our view of the sun. They're on two separate sides of the Earth. And that means in terms of rising and setting, as the sun sets in the sky on September 21st, Saturn is going to rise at the very same time. So they're opposite sides of the sky.
All right, another question over here.
What is the meteorological explanation for the hexagonal storm on the North Pole when Saturn's rotation would cause tangential rounding? Why would it be hexagonal and have angular views or momentum such as that?
I would love to learn more about that storm. I don't know much myself right off the top of my mind. I think that would come maybe with a show in the future. But yeah, I don't know enough about it. I know when they first discovered it, they were right away fascinated, probably for some of the reasons you're describing there. But yeah, I don't know enough about the storm itself at the moment.
So it's not a city.
No. That'd be cool too, though.
It makes me wonder if it ends up being sort of a frozen gas that just that just happened to be. Have anybody ever been to Ireland and have seen the up in Northern Ireland? They have those rocks that are very sort of angular like that. And I'm sorry, what? Giant's Causeway. Thank you. I couldn't remember what that was exactly. So.
Could that storm be crystalline then?
Possibly.
It is on the north side.
The blue color could be indicative of some methane. I mean, Saturn does have some methane in its atmosphere, so that could be part of it too. That's often what gives the ice giants some of their blue color as well. So that's possible.
And yet it doesn't occur down in the South Pole.
Yeah, that's interesting too.
I guess a TBD. Well, anyway, if you have any other questions, Jenny, if you want to sort of hang here for a little bit. Jenny, thank you once again for just a well presented presentation.
Thanks, everyone.
And now we have a rule here that you can't leave Kopernik until you look through a telescope. So leave your keys up here. And so when you go out through the double doors just on the other side of the lobby, take a left and then you'll see a door to the right, and then there should be at least one, possibly two telescopes open there. We'll also have some scopes open in the field, out in the blue, not exactly in the field, but it's a blue walkway out there. And so thank you very much again for coming, and look forward to seeing you again in the future.
Maybe we'll see you at 1 o'clock in the morning later.
Also, yeah, probably in about 10 minutes, Dr. David Carter will do a laser star tour. So that'll be out in the open area there.
Oh, thank you.